Sharks lose teeth constantly. It barely matters. New ones just grow right back in. Humans get exactly 2 chances. Baby teeth, then adult teeth. After that, you're on your own forever. Lose an adult tooth to an accident or decay, and nothing is coming to replace it naturally. So why did evolution give sharks an endless supply, but leave us with just 2 limited sets? The answer involves a genuine evolutionary trade-off, and something genuinely exciting happening in labs right now. Scientists in Japan recently began real human trials for a drug that may let adults regrow teeth. Yes, an actual drug. And it's based on something surprising already hiding inside your own jaw. Let's get into it. Let's start with the basics. Humans are what scientists call diphyodont, meaning we get exactly 2 sets of teeth. The first set, baby teeth, typically starts appearing around 6 months of age. Around age 6, those baby teeth begin falling out, replaced one by one with permanent adult teeth. Once all your adult teeth are in, usually by your late teens, that's the final set for the rest of your life. No natural third set is coming, no matter how many decades you have left to live. This raises an obvious question. Why do we even bother with baby teeth first, instead of just adult teeth from birth? The answer comes down to simple physical space. A baby's jaw is far too small to fit full-size adult teeth. Smaller baby teeth fit the smaller jaw perfectly during those early years of rapid growth. As the jaw grows larger throughout childhood, it gradually makes room for the bigger permanent teeth to follow. It's a practical, temporary solution to a basic growth problem, not a flaw in the system. Now let's look at animals that never stopped regenerating teeth throughout their entire lives. Sharks are the most famous example. Some species can go through tens of thousands of teeth in a lifetime. New teeth continuously form in rows behind the front ones, moving forward as older teeth are lost. Many reptiles show a similar pattern, replacing individual teeth throughout their entire lives as needed. Scientists call this pattern polyphyodont, essentially unlimited tooth generations, compared to our limited 2. A single shark might go through tens of thousands of teeth across its entire lifetime without any real cost. For a shark, losing a tooth is barely a minor inconvenience. For a human, it's a permanent, lasting loss. Elephants have a genuinely unique twist on tooth replacement worth mentioning here. Instead of new teeth erupting vertically from below, like in most mammals, elephant teeth move in horizontally. Elephants go through 6 total sets of molars during their lives, each sliding forward to replace the worn-out one. Once that 6th and final set wears down, elephants can struggle to chew effectively, which affects their lifespan. It's a completely different solution to the same basic biological challenge every animal with teeth eventually faces. So why did mammals like us trade away that endless supply for just 2 limited sets? The likely answer involves tooth complexity. Mammal teeth are far more specialized than most continuously replacing animals. We have several distinctly shaped tooth types, each precisely fitted for a specific chewing function. That precision requires teeth to fit together in an exact, stable bite alignment, called occlusion. Constantly replacing teeth throughout life would repeatedly disrupt that careful, complex alignment. Evolution appears to have favored fewer, more precisely fitted generations over endless, simpler replacements. Here's the genuinely surprising part. Most humans actually still carry hidden remnants of a potential third set. Dental researchers have identified small tissue remnants called the successional dental lamina in human jaws. This tissue is essentially the leftover biological starting point for growing additional teeth. In most people, it simply stays dormant for an entire lifetime, never activating or doing anything at all. But its presence raises a genuinely exciting question. What if scientists could safely wake it back up? That question led to one of the most exciting recent discoveries in dental research. In 2021, a team at Kyoto University, led by Dr. Katsu Takahashi, published a breakthrough study. They identified a specific protein called USAG, one that actively suppresses the growth of extra teeth. Essentially, USAG-1 acts like a biological brake, keeping that dormant third-set tissue permanently switched off. The researchers developed an antibody specifically designed to block USAG-1 and release that brake. In mice missing teeth due to a genetic condition, a single dose of this antibody triggered whole new teeth to grow. The team later repeated this success in ferrets, animals with a two-set dental pattern similar to humans. Let's dig a little deeper into how this actually works at a biological level. USAG1 interferes with two important signaling pathways involved in tooth development, called BMP and WNT. Think of these pathways as instructions telling dormant tissue when it's safe to begin forming a new tooth. Normally, USAG1 keeps interrupting that instruction, so the dormant tissue never receives a clear green light. The antibody treatment specifically blocks USAG1's interference without shutting down the pathways themselves. That's an important detail, since BMP and WNT signaling are also involved in many other important body processes. A more blunt approach could cause serious, unwanted side effects elsewhere in the body. This precise targeting is exactly why researchers are optimistic about both its safety and its actual effectiveness. This research has now moved from animals into genuine human clinical trials. In late 2024, researchers began the first human trial of this antibody drug, now called TRG-035. The initial trial involved 30 adult men between 30 and 64, each missing at least one tooth. This first phase is mainly focused on confirming the drug is safe and finding the right dosage. If these results hold up, future phases plan to test the treatment in young children born without certain teeth. That specific condition, called congenital anodontia, could be a major early target for this treatment. Some researchers involved have expressed hope this could become a real option sometime around 2030. To be clear, this is still early-stage research. Safety and long-term effectiveness in humans aren't fully confirmed yet. If this research continues to succeed, the potential impact would be genuinely significant. Right now, missing teeth are typically replaced with artificial solutions like dentures or implants. A working regrowth treatment could offer an actual biological alternative, a real tooth instead of an artificial one. For children born missing teeth entirely, this could be an especially meaningful, life-changing option. It's a great example of a strange, evolutionary leftover turning into a promising modern medical breakthrough. Quick pause before we continue. Take a guess. Do you think this treatment, if successful, would work the same way for every single missing tooth? Not necessarily. Researchers are still studying how well this works for different numbers and locations of missing teeth. Early research is promising, but real-world results across different cases are still being carefully tested. Let's clear up a few common myths before we wrap up. Myth 1. Humans have never had any biological capacity for a third set of teeth at all. Not accurate. Most humans carry dormant tissue capable of forming additional teeth, just permanently suppressed. Myth 2. This tooth regrowth drug is already available for anyone to use today. Not true yet. It's still in early human trials, focused first on safety, not widespread public use. Myth 3. Sharks and humans lose teeth for basically the same underlying biological reason. Not quite. Our systems evolved along completely different paths, favoring precision over unlimited replacement. Myth 4. Baby teeth are biologically unnecessary and could be skipped entirely. Not accurate. They're a practical solution to limited jaw space during early childhood growth. Myth 5. This new drug works by implanting artificial or lab-grown teeth into the jaw. Not accurate. It's designed to trigger your own body's dormant tissue to grow a completely natural tooth. Myth 6. Only humans and a few closely related mammals ever lose the ability to regrow teeth. Not true. Most mammals share the same limited, two-generation dental pattern, not just humans. Let's wrap up with a few fun extra facts. Tooth enamel is actually the hardest substance in the entire human body, harder even than bone. Despite that strength, enamel can't naturally repair itself once seriously damaged, unlike most other body tissue. About 1% of people are naturally born with either extra or missing teeth due to genetic variation. Some of those naturally occurring extra tooth cases actually helped researchers first identify the USAG1 pathway. It's a nice example of a rare natural variation directly leading to a promising modern medical breakthrough. Okay, let's bring this all together. Humans get exactly two sets of teeth because our teeth evolved to be complex and precisely fitted, not endlessly replaceable. Baby teeth exist simply to fit our smaller early jaws, making way for permanent teeth as we grow. Most of us still carry dormant tissue capable of forming a third set, just permanently suppressed by a protein called USAG1. Scientists have developed an antibody that blocks that protein, successfully regrowing teeth in mice and ferrets. Human trials began in 2024, and if successful, could eventually offer a real biological alternative to dentures and implants. All from a strange evolutionary leftover quietly sitting in your own jaw this entire time. If this answered a question you never knew you had, that's exactly what this channel is about. So if you enjoyed this, hit subscribe so you don't miss the next one. It genuinely helps this channel grow, and it takes about 2 seconds. Drop a comment and tell me which part surprised you the most. Was it the elephant's horizontal teeth? The human trial drug? Let me know. And if you like this video, go ahead and tap that like button. It's a small click that genuinely helps this channel keep growing. There are hundreds of everyday questions just like this one waiting to be explored. Things you've never questioned about your own body, sitting right there in the mirror. That's what this channel is all about. Toggling your curiosity on, one question at a time. One more thing before you go. Tap that notification bell too, so you actually see it when the next video drops. Next time, we're tackling why flamingos stand on one leg for hours without falling over. It's a surprisingly clever energy-saving trick, and you will not guess the mechanism. I'll see you in the next one.